So, students, good morning. So, I will discuss calculus of variations today. So, I will give a brief introduction of calculus of variation first. So, it is also called variational calculus or calculus of variations. So, now in calculus of variation, what we will do, first of all, I consider a function, or we can say integral, the definite integral I, function of y, that is iy is equal to x1 to x2 f of xy dy dx. So this is the integral where y is equal to fx, where y is equal to fx is a curve, the curve joining two points a x1 comma x2 and b y1 comma y2, and dy dx is the derivative of y with respect to x. So first problem of calculus of variation is that to study how this integral 1 varies when the curve y is equal to fx varies. Now we restrict our study here to the case where the points a and b are fixed. So here a and b, these 2 points a and b are fixed. So in particular we are interested to find the maximum or minimum value of I. Since I depends on the function fx, we say that I is a functional. So all of you, I think you know what is functional, because in functional analysis we have already studied the definition of functional. So I will give a brief description of functional later on. So in calculus we have studied maxima minima. For a given curve y is equal to fx, we propose to find the values of x for which the function y attains maximum or minimum value. So we find that a necessary condition is that the derivative dy dx is equal to 0 for maxima and minima, and the points where dy dx is equal to 0 are called the stationary points. We now like to show that the determination of stationary values of the integral I may be reduced to the above problem of calculus. The fundamental result is due to Euler. Mathematician Euler first find out the condition so that the integral I attains maxima or minimum value. So that's why it is called Euler form. So we will study later. Now what we want is that to find the particular function y is equal to fx that gives to 1 its minimum or maximum value. In calculus of variation we will discuss this kind of problems in details. This includes the problems of finding out the shortest distance between 2 points on a given surface, on a given surface. So suppose this is a surface and there are 2 points, A here and B here. So shortest distance, suppose this. So we will find out this shortest distance. So in Euclidean geometry, the shortest distance is a straight line. But in a surface, when we want to find out the shortest distance from 2 points, between 2 points, then that will be geodesics. That is called geodesics. So this is one problem. Another problem is the quickest descent. Finding out the quickest descent between 2 points. That means, suppose in some heights some particle is there. So here's some particle. So we want this particle to reach this point, and there is a height, some height is there. So gravity is working here. So suppose gravity G is, so when a particle coming this points, so this will follow this path because of gravity. So this is the quickest descent. So finding out this descent is also a application of calculus of variations. Now third thing is that the surface of revolution, finding out the surface of revolution of minimum area. That is, suppose this is x-axis and something is revolving. So suppose this is a curve. So if it will revolves, then it is a three-dimensional picture. So this is axis. So suppose image of this point is there and image of this is here. So this will generate a circular path. Also generate a circular path. So this is this. So this is the surface after revolution. So finding out the minimum surface area is also a application of calculus of variations. Now the techniques of solving the problems of minimizing or maximizing of integral 1, this is this integral, and related definite integrals are closely connected with the problems of maxima and minima in the elementary differential calculus. Now what is functionals? What is functional? I think all of you know this, but for recalling the definition, I am discussing here once again. Functional. So a mapping, functional is nothing but a mapping which assigns a definite real number to each function belonging to the same class is called functional. So thus we say that a functional is itself a function or a kind of function where the independent variable is itself a function. So for a function, what happens? One suppose y is equal to fx is a function. So here x is independent variable and y is dependent variable. So suppose if y is dependent variable and x is independent variable, so if x is also depends on some variable, that is suppose u, then we say that this is a functional. Y is equal to fx is a functional if x is a function of u. So that means u depends on x depends on u. So x is also a independent on u. X is dependent on u. So functionals are often expressed as definite integrals involving functionals involving functions and their derivatives. So functionals play play an important role in many problems in analysis, mechanics, geometry, geometrical optics, theory of elasticity, and quantum mechanics, etc. Now I will give some example of functionals. So examples of functionals. Examples of functionals. So the arc length L of a plane curve y is equal to x connecting to given points x1 y1 and x2 y2 is a functional. So we express L as L is equal to L of yx, this is equal to integration x1 x2 1 plus dy dx whole square dx. This is length, arc length. So this is a functional because here yx is a function, itself a function, and L is function of yx. So this is a functional example of functional. Another example is number 2. The area, surface area or area S of a surface bounded by a given curve C. So that S is a function of zxy, that is I am taking from elementary calculus, so no need of explanation. All of you know this, 1 plus del z del x whole square and del z del y whole square dx dy. So this is surface area and this is also a functional. So in this way we can give also, there are so many functionals. So thank you all of you. This is my first class of calculus of variations. So I will discuss the other things in next and onward classes. Thank you all.